what I would have prepared is some hints on how to run Elmer, both on HPC, but also on personal computers. But maybe the discussion is, more important. So discussion, and if discussion ceases, I can put you to sleep with that. There's a general also mentioning that, for instance, that there are Docker containers ready to use, and how to run it, install it on Ubuntu, where to find your Windows image.
There's a question.
Yes, great.
Alexis, you wanna come off mute?
Yeah, thank you. So OpenFOAM used to have issues with simulations that that needed a lot of processors to run, because each processor saved their own files.
Yeah.
And if the simulation is big and it runs for a long time, then it accumulates a lot of files. How do you manage the output in Elmer? I don't know if you're avoiding these kind of problems with a more clever way of handling the output.
Yes, very good questions. I'm aware of that issue of OpenFOAM, simply because I'm working at a data center and we have been haunted by that issues. What comes to Elmer, so I would have that tomorrow, particular what comes to mesh or data handling in parallel cases. But shortly, of course, we have to partition the mesh. So you need generally for input, if your number of MPI ranks is n, you need n different mesh input files. And you also create n different output files, but we don't split. Actually, that's not true. So you can optionally have restart files, but you can write them at a certain interval. So you don't have to, for instance, if you do 10,000 time steps, you can say, write me out every 1,000 times, and then you have just a set of 10 output files. So you can very much tailor those output files in size, but generally you're talking of basically 3 times n, where n is the number of MPI tasks of separate files for an Elmer run. Having said that, particularly the output files, what comes to VTK files for ParaView2View, you can highly reduce them. You can go down in precision, because generally for the visualization, you don't need a high precision. You can avoid, for instance, writing out, if it's not necessary, 3-dimensional fields. So if you just, for instance, are interested in the surface velocities of an ice sheet, you just write out the surface, thereby highly reducing the amount of written out files. What you have, and I'll show this also, I think, tomorrow, is you have the possibility to write out ASCII files of anything there is, 3-dimensional surface lines, you name it. And these, of course, can go very extensive, but generally also these are just a set of n, again, where n is the number of MPI ranks in your simulation files. So I dare to say that the problems we create with Elmer are quite remote from those you generally have with the huge amount of output files of OpenFOAM. But don't point fingers to OpenFOAM, I guess they need those files, I don't know.
Yeah, well, OpenFOAM sort of fixed their problem, accumulating the results into a single file.
Yes, yeah. And even for some of the ASCII output, at least, you have the possibility to collect them and write them into a single file.
Mm-hmm.
So you can do a parallel reduction of things without too much of a penalty on the performance. That's possible. and said
Okay.
you can, by certain switches, reduce the amount of data being. But if you go flat out, of course, you can also get a Lustre file system to crash with Elmer. No problem.
Okay. Thanks.
Any other question? Well, should I shortly? Yes. Yeah. I try to be swift with that. Yeah. Okay. Well, then shortly on running Elmer. That would have been an interactive question, but I'll leave that to you to answer. So what your primary platform is, if you're on a Mac like me, not on freewheel, because it was the only machine that has a certain way to work and still show PowerPoint presentations. Generally, I work on Linux. You are in troubles because Mac is always trouble to compile with, I have to say, but it's possible. But yeah, there's a Windows executable, downloadable, and on Linux, you're anyhow good. You can compile it from source, or if you are running a Ubuntu system, you can use Launchpad to download it. Okay, so 5 ways. Compile from source code, which is usually always a good thing because then you can tailor your Elmer installation. You can even leave certain parts out. So if you're not interested in the ICE part, you just say in the CMake with Elmer ICE equals off, and you're good to go. You can even cherry pick certain solvers. So you can have a mini version of Elmer that, for instance, just has the electrostatic or the fluid heat transfer solver. You are free to do what you want when you compile it. Pre-compiled packages there are on Linux and Windows. Linux would be basically Ubuntu. You can run an appliance which we regularly provide for courses and is downloadable without any warranties taken, of course. I think I based it on Ubuntu actually, 22 LTS from our platform. I'll show you later. You can run it in a predefined container. There are recipes on the GitHub repository how to build yourself a Docker container of Elmer. Or if you're doing HPC, generally you will run it remotely, where some guy has been spending sleepless nights to install Elmer, like Onyx or Lumi. That is the thing we're doing tomorrow, actually. From source, there is a GitHub repository. Just check for Elmer FEM or Elmer CSC, and you will find it. I think, Maciej, I have a PDF version of this talk, maybe make it online that people then can refer to that links. Yeah. Okay, excellent. Yeah. Which reminds me that I should update this. I think is an outdated link, but I will update with the right link before I start with you. But there are instructions on how to compile it, so you're not alone there. Minimum requirement, what you need is a suite, preferentially the GNU suite that works or is tested with best of a C, C++, and Fortran 90 with the 2008 minimum standard compiler. You need CMake, and yeah, generally need some patience in compiling. What we strongly recommend, else at least if you want to go parallel with the distributed memory approach, you need an MPI that would, for instance, apply to supercomputers. But also the BLAS, particularly on supercomputers, we learned that generally you want to have a for the platform optimized version. If not, we are providing that, but it's a very rudimentary version of BLAS that generally really sucks in performance. So we had once on an older gray machine, it was really bad. We had a 20 times increase of performance just to replace the bus with the system bus. So be aware that, particularly on HPC systems, that is a critical thing. And then you can add more options there. So all these additional libraries are optional, like adding Hypre, MUMPS, you name it, linking it in. On Windows, we have on the NIC FUNet Phi platform, which is a very old file distributing system of CSC. On a side note, to go like in history, where a guy named Linus Torvalds published his first version of an open source system. The original files are still there. I checked them. So this NIC FUNet Phi also contains, is basically the home base of Elmer also. And we have, I think, daily made new Windows binaries there. So if you're on the Windows side, just go there and install it. You might be forced to do some system adjustments. Always read the README before you do, particularly before you contact us in terms of problems. For Ubuntu, we have Launchpad. So these would be the sequences of commands you have to give. You have to apparently have sudo rights, so you have to have an administrative enabled account or a nice system administrator who does it for you. Virtual appliance, I don't know if this is still relevant. I think virtual machines are kind of dying out, but they are quite nice for courses actually. At least the machine part of VirtualBox is still open source. I think it should also work on QEMU or so. Yeah, you're free to do what you want. Basically, if you install a virtual machine, then it's upon you to compile Elmer inside, or you take one of our ready-made images, which, disclaimer, come without warranty, but with an Elmer and a PowerView and a Gmesh installed therein. It's provided by an OVA file, which you just read into VirtualBox. They are not updated very often, so basically once per year when I have a new course with Elmer Eyes. Docker, there is ElmerFem Docker repository. It's not maintained at the moment, but there is also a Docker recipe in the main one, so that should work. Again, basically in Docker, what you do is setting up a Ubuntu system or whatever you name it, and then compile it yourself, but the recipes are already written. Yeah, I think maybe I skip that one because this is very philosophical. Yeah, what I wanted to say, and this is almost the end of the talk now, is you might recognize the one on the left upper corner, which I showed in an example. For Elmer GUI, there are 15 examples which you basically can read in and then test out. And I think, oh no, there are even more. And I think one should be, yeah, tutorial 24, because there was fluid structure interaction mentioned here. This is a bending beam in a flow, two-dimensional only, but basically I think it should give you the idea how the fluid structure interaction works. So basically from every field, there are examples here. And I end with that. So that's basically the site with all the links that are relevant if you want to dive deeper. We also have a YouTube channel. During Corona, we were forced, of course, to go completely online. There are a few webinars that have been recorded, also one in parallel computing that are available from there. And if you have a particular question that you cannot find answered on any one of these sites, you can drop a mail to Elmer Adden at CSCFI, and particularly my colleague Peter Raubach, who is managing the code at our place, usually answers in between 24 hours for that. Okay, so thank you for your attention. This was quite long. I hope it was not too boring. So thanks for your attention again. Any questions left to that part? Okay.
Let's thank our speaker. Thank you, Thomas. And just as an intro and announcement that tomorrow we have a second session which will look at how to run Elmer on Cetonix. So for this we'll have the course account. So even if you don't have access to Cetonix yet, you will be provided with the account password and then some instructions on how to run your first job on Cetonix first, and then first Elmer job on Cetonix as well. Thanks, Thomas, again.